Hello Year 11, this is your lesson on vectors in 3 dimensions. So we're going to look at how, how we write vectors in 3 dimensions and then how we can solve problems with them as well. So Cartesian coordinates in 3 dimensions, we introduce a third axis which we call the z-axis, and coordinates in 3 dimensions are given in the form x, y, z. Now one way to imagine it could be that you lie down the x and y axis so they are flat and then project the z axis out from the origin. Sometimes I find it easier, because I think it's probably because I'm writing on a whiteboard, to think of the x-axis and the y-axis drawn on the whiteboard and the z-axis coming out of it. But as long as you know what you're talking about, they don't actually have a defined direction, they are just all at right angles to each other. So in this example, we're going to find the distance from the origin to the point P. We're given the coordinates of point P here. Now you don't have to draw a diagram, but I'm just going to show you so you can visualize what's going on. So the point P is 4 along the x-axis, 2 along the y-axis, and 5 along the z-axis. So to get from the origin to point P, I'm looking at this vector here. We can use the 3D version of Pythagoras' theorem to find the length of this line segment. So it's just the square root of x squared plus y squared plus z squared. So in this case, I've got 4, 2, 5. Add those together and we get the square root of 45. That can be written as 3 root 5, or if I want to know as decimal, two decimal places, it's 6.71. Remember that in tests you should always be giving your answers as exact values unless told otherwise. However, sometimes it can be useful just to see an actual size of something. Okay then, so the 2-dimensional vector results can be extended to 3 dimensions, where we use k as the unit vector parallel to the z-axis. So we've been using I and j up until now. Now we've introduced k. Just a quick reminder, they're the standard unit vectors. They're parallel to the x and y and z axes respectively in the increasing directions. This is what their column vectors look like. I can write the vector xi plus yj plus zk as xyz. And the modulus or magnitude of this vector is the square root of x squared plus y squared plus z squared. Let's have a look at an example now. So I'm given 2 vectors in 3 dimensions, a and b. First I need to find a plus b. So that's simply this one plus this one. Then I collect the like terms up. So I've got 2 i's here, I've got 1 j, and I've got negative k plus 7k. That gives me 2i plus j plus 6k. b minus 3a, make sure you write that out with brackets to begin with. That's going to minimize your chances of making a mistake with the negatives. So I've got I've got minus 3i, so that gives me negative 2i. I don't have any j's in the first part, so I've just got negative 3 times j, so that's minus 3j. And then 7k, then I've got minus 3 times minus k, so that's plus 3k. The modulus of the vector a is just going to be the square root of 1 squared plus 1 squared plus negative 1 squared, which is the square root of 3. Here I've got a different vector a. I'm asked to find the unit vector in the direction of a. So I need to find the modulus of a by doing 3 squared plus 2 squared plus 2 squared. That gives me root 17. And so my unit vector in the direction of a, 1 over root 17 times the vector a. Unless told otherwise, it's fine for me to have an irrational number in my denominator. Pause the video now while you have a go at questions 1 and 3. Okay. This is all the information I went through before. Often we're given shapes that have vectors. So here we're given a cuboid, and I'm given 3 vectors that lie on the cuboid. I've got to find each of these vectors. First step, if you don't have a diagram, draw one. So O, A, E, D, make sure I've drawn it in the right order. Now, let's label my edges of my cuboid with the information that I know. So I know that OA equals 3J. So I'm going to pop that there. Underlined my J with a tilde because it's a vector. OC is K, and OD is I. Now, because this is a cuboid, I know that all of the angles are right angles. I know that OA is equal to CB, GF, DE. I know that OC is equal to AB, EF, and DG. And I know that OD is equal to CG, BF, AE. So let's start by looking at our first part, OE. So I can say that OE is equal to OA plus AE. OA I already have is 3J. AE, that's equal to OD. So that's just 3J plus I. The next one, OF. So I already know how to get to E, and then I just need to go up here. EF is the same as OC. So that's going to be 3J plus I plus K. GF, G to F, that's just the same as OA, so that's equal to 3J. GB, that's G to B, well that's just the same as DA. So I can go D to O, O to A. D to O is the opposite direction to OD, so that's negative I, and OA is 3J. So M and N are the midpoints of OD and GF respectively. So let's put those points on. That's M and N. Now I'm asked to find the magnitude of the vector MN. For me to find the magnitude, I need to know what the vector is. So to get from M to N, I can go M to D, D to G, G to N. M to D is half OD. DG I've already spoken about before. GN is half of GF. GF is equal to OA. So I can rewrite like this. So OD is I, OC, which is the same as DG, is K, and OA is 3J. Now, to find the magnitude, I use Pythagoras' theorem. So the square root of a half squared plus 1 squared plus 3 over 2 squared, root 14 over 2. You'll notice that the I and the J and the K, I've been writing them in different orders. We think of them as being I and then J and then K in alphabetical order, but it doesn't actually matter what order you write them in. However, you might find it useful to always put I's first and then J's and then K's because it makes it easier to compare vectors. Now you can answer the remaining questions from 20F, question 2 and 4-6. If you have any questions, ask your teacher. Thank you.